Don Victory, the founder and chair of Energy Mentors, and we have a guest speaker today, Jey Arjunan from Aspen Technologies. He's the senior director of sustainability, and he's going to talk about sustainability pathways for communities. So, Jey, over to you.
Thank you, Don. Is everyone able to hear me well? Okay, thank you so much. Okay, first I want to thank Don and Judith for inviting me to present here. And good morning, good evening, everyone, depending on wherever you are in the globe. And really excited to be here today to talk about how we can use artificial intelligence and engineering principles to solve real-world problems. Okay, let me continue. So today, what our focus? Our focus will be on a conceptual project, community plastic recycling and AI-powered solar micro hub. This is not really an actual implementation that has already happened, but an exercise to help you think about structuring and executing a sustainability project. So by the end of this session, what will be your takeaway? I hope you will be able to gain insights into cross-disciplinary collaboration, problem solving, and how AI and solar power can work together for bringing a positive impact to the environment. Next slide, please. Okay, so let's now talk about the problem a little bit. Okay, so why do we need such a project? The biggest challenges in waste management today include inefficient recycling methods and high energy consumption. Imagine a system where we can use AI-powered sorting to improve plastic recycling, and it is entirely powered by solar energy. This is what we are going to conceptualize today. This system consists of three components: AI-driven sorting, a system that identifies and categorizes plastic types using computer vision, a solar-powered microhub, energy-efficient shredding, and heating processes powered by the sun. That's really interesting, right? And also an IoT-based monitoring. When I refer to IoTs, you might have heard about this. That is called the Internet of Things, which has sensors to track energy usage, system performance, and sustainability impact. Together, these elements create a smarter, self-sustaining, and recycling stations. So I want to pause here. I know if you have any questions, you can ask me. But at the same time, I want to ask you a question. What are some of the common issues with current recycling methods? If anyone want to speak up, or if you want to chat or put a comment in the chat, I would like to hear.
Hello.
Yeah, go ahead.
Hello, my name is Shima. Hello?
Yes, we are able to hear you.
Okay, I want to ask if this project is in process. You are doing on it, or it's the project you want to do in the future? Thank you.
Okay, that's a great question. So this is not a project in progress. The objective here is to help you how you can think about or conceptualize a project and then complete it. So this project doesn't necessarily mean that the team or you need to select the same project for your purpose. We are just giving you an example of a project, and then how you can conceptualize, how you can work together, and how you can execute it. This is just helping you with an example to think about a future project.
Okay.
Does that answer your question?
Yeah, I get it. Yeah.
Okay, thank you. Thank you for your question. Okay, moving on to the next slide. Okay. Okay. So now let's think about like how. So why do we need such a? So let's think about now. Let's break down how AI improves recycling efficiency. Okay. AI can help in three ways. Specific to this project, AI could assist sorting using computer vision. The system can identify plastic types in real time. Instead of relying on manual sorting, which is a process which is prone to errors, right? AI can speed up, imposes the accuracy of waste separation. Also, it can help you with contamination detection, right? Contamination is a big problem in recycling. AI can detect if plastic is too contaminated for recycling, helping prevent wasted processing efforts. Shredder optimization, sensor adjusted shredding speed based on the type and the condition of the plastics, reducing energy consumption and increasing efficiency. These AI applications help improve recycling rates and make the process more effective. Yeah, as we are in this slide, I may ask you, how else could AI improve recycling? Here we talked about AI. Is there any other ideas you want to pitch in? Does anyone have any other ideas? You can type it in the chat, or you can talk. I think towards the end of the calls, I think many of you can talk.
Hello.
Oh, someone wants to talk. Okay, go ahead.
I have an idea of collecting this waste material from urban homes. We can build the AI that will build an AI and integrate it with this recycle bin. That recycle bin will be used in different home where the home or anywhere they can fulfill that waste, and that AI communicate with the collector, which will go to bring it to bring it where that project will be developed or will be working. Yeah, just as I see this AI is looking in where the collection of the waste material will be separated from the biomedical, from the biodegradable, but we can build an AI that will be integrated with that recycle bin in order to communicate with the waste collector. Yeah.
Great. Yeah. Yeah, that's a wonderful idea. Great. Thank you for this. We will definitely, that's really good. I think this is an idea. Of course, many of you in this team, in this meeting, might have listened to it. Yes, that's a great one. Judith, I saw there is an idea that was typed in the chat. If you can read out.
Yes, Raj Sharma said we could use AI for analyzing the flow systems of wastewater through different pipelines and optimize those for avoiding waste of water and reuse water.
Excellent. Thank you so much for these ideas. I definitely think like some of these ideas that you can incorporate in your project that you are conceptualizing and doing as a part of this program. Okay, thank you so much. Let's go to the next slide. So now we talked about AI, and of course we got a lot of interesting ideas from the audience. Now, how do we power this system in a sustainable way, right? Instead of relying on conventional electricity, we use a solar micro hub, okay, that can predict solar energy availability and optimizes system operations accordingly. Use IoT sensors to monitor energy consumption and performances. Operates as a self-sustaining unit, meaning it can set up anywhere in a community without needing a grid connection. Okay, this not only reduces carbon footprint, but also makes the system cost effective for the undeserved areas. Okay, so at this point, we would also like to do a polling. In your opinion, which area of sustainability can benefit the most from AI? I think there is a comment in the chat we can read.
Yes. Shima Chris wrote, AI-powered sensors and IoT devices can track flow rates, pressure, and quality in real time. Machine learning algorithms can detect anomalies such as leak or blockages and alert operators before significant water loss occurs.
Excellent. Thank you so much. I think some of these are very critical, and thank you for putting those ideas. And we are also discussing some of your great ideas in this presentation in some of these subsequent slides. There is one more comment.
Yes, Raj Sharma wrote, to mitigate the intermittency of renewables, this would be the most primary use of AI in the future.
Great. Thank you so much. I think let's move on to the next one. Now, let's talk about some of the key innovation and challenges that you can contribute. Okay. So we talked about AI, we talked about engineering, we talked about sustainability. So basically, this project is bringing together AI, engineering, and sustainability, but also it presents some challenges, correct? Definitely, when we bring all of these together, there are challenges. AI improves sorting efficiency, but plastic contamination can still be a issue, right? Solar energy is great, but it varies based on weather conditions, requiring smart power management, which is one of the biggest challenge. Even we haven't solved it completely, correct? Because weather situation are going to change. The availability of solar is going to vary considerably in a single day. And AI and Internet of Things tracking can reduce manual errors. But training these models, right? We are relying on artificial intelligence models, and training these models to recognize waste types requires some time and data, correct? That's why we really strongly, and we want to strongly recommend why cross-functional collaboration is crucial in solving this process. So I want to ask you, the audience, I have mentioned few challenges here. What other challenges that you think that you would face during the execution of this project? Yes, I think we had a lot of response from the previous questions. Yes, please go ahead and type it in your chat. What could be some of your challenges, or just unmute yourself and you can ask the question.
No, someone's asking, can you re-ask the question?
Okay, so the question is basically, I have mentioned a list of challenges here, right? Even though we are using solar, there is a challenge with weather availability, correct? AI can track plastic waste, but there is a problem with contamination. Data could be a challenge. There are several other challenges, right? I have mentioned here in this slide. So in addition to this, what other challenges you would
Hey, Jay, can I offer one?
Yeah, definitely, Don.
Okay, and this often I've seen over my career happen. Management of change, especially the human interface. So you have AI, you have engineering sustainability. AI and technology can rapidly change, but human behavior sometimes doesn't. So anytime implementing new technology could be a challenge. So for example, if you're trying to get people to sort out their house and do things differently, that tends to be an obstacle. To the degree that you have the AI within a contained ecosystem, which is controllable, like a sorting facility, you're probably better off because you're not dealing with having to change human behaviors. So that's just a general observation on technology adoption. Getting humans to change takes a little bit more effort rather than changing engineering systems, if that's helpful.
Oh, yep, definitely. I think that's a very valuable point. And I think, do you think, of course, you mentioned the challenger. So based on your experience, could you also share what kind of some of the initiatives that we can take to improve it, or can you share us some tips on that?
I think it follows a general innovation type success path. So focus on minimum viable products, go in and do real world experiments rapidly. So applying AI in a sorting center, if you're already partially automated, is probably a more successful path if you're just trying to improve the performance of robots. And you could probably do a very quick series of experiments, or adjusting the power system and solar panels and timing. Again, if you're just dealing with engineering type systems. So in general, defining those minimum viable projects and implementing very rapidly and getting those learnings and slowly compounding those lessons is one key technique that many people use. If you're trying to change the humans up front in a system, that might be a little bit more difficult. So it's just using the general lessons on innovation and minimum viable products and applying it in this new evolving field would be where I would suggest people start. Comments?
Great insight, Don. Thank you for sharing with us, because this also, helped me learn, as well as added some insights, like how I can approach this problem in the future. Yes. Any comments from the audience as well?
It's another challenge I was thinking about. It's about the bridging AI engineering and the sustainability. AI-driven grid stability and engineering storing management. I think it's another challenge, because about as renewable energy sources like solar and wind are intermittent, and AI must ensure grid stability by predicting energy demand and optimizing battery storage. I think you get it. Another thing, I think it's about efficient energy storage solution that are still challenging, requiring advanced AI algorithm to balance that energy distribution and minimizing waste. Yeah, thank you.
Oh, thank you so much. Thank you so much for offering your thoughts. Any other comments? Don has a feedback.
Well, Jay, that Raj posted a comment in the chat, so let me read it to you.
Okay.
Failure to ineffective measurement or use of defective data can cause large problems to go unseen. AI can track what we tell it to track and predict, but first we have to determine which observations to take into consideration, not only geographically, but also with the experience, which most humans, professionals can sense a new problem and react accordingly, but AI cannot perform any such urgent actions by themselves. Comments?
Yes.
Yeah, I think that gets back to a little bit to humans still can follow the scientific principles of they sense a problem, they can offer an hypothesis, maybe get AI to do it, but someone still has to do that reality check on what the data is saying. Are you looking at the right data, and are you forming a hypothesis that can be tested?
That's a good insight. And when it comes to data, what I want to, yes, the challenge is there, right? But at the same time, the pace which the AI science is improving, there are some new techniques. But of course, I don't mean to have a strong technical presentation here, but we can sometimes talk about some of the data challenges, right? You are perfectly right. The model is going to behave as good as the data that we feed, correct? But the current AI technology has some improvements or some ideas, some strong foundational mathematical methods that can improve that, which we can talk in other discussions. I can also give you some ideas about, like, before even we build the model, what do we really need to do with the data, right? What is feature engineering? What is exploratory data analysis, and so on? Definitely, I would love the opportunity to share some of the technical details associated with that in a later time. But thank you for putting those thoughts. Thank you. Okay, now let's get into the next slide. Okay, now let's talk about this. This is a very, very important topic, okay? So we talk about AI, sustainability, engineering principle. What does that mean? Bringing people together. Don brought an important point of human element to it. Here is also a human element to it, right? Collaboration is so important. So one example I always see it is whenever there is a Nobel Prize award winner nowadays, it's not just for one person, correct? It's for scientists from different parts of the world coming together and solve a problem in physics, solve a problem in chemistry, and so on. So now I can see in this meeting or in this session, we have engineers all over the world, correct? So we need collaboration. Okay, so now let's back into the project. This project requires expertise from multiple engineering disciplines. Mechanical engineers, they can help with the design of shredder and compression mold. Electrical engineers, they can help us set up solar panels and energy storage. AI engineers, computer science engineers can help us develop image recognition and automation for sorting. Environmental engineers, they can help us analyze waste diversion and CO2 savings. This shows why engineering projects today are highly interdisciplinary. Even as a specialist, you need to work with experts from other fields. Okay, any thoughts on this before we get into the execution strategy?
I have to jump in here and say that is a spot-on message. That as a chemical engineer, I could do a lot of optimizations within like process engineering, but I found in my career the biggest opportunities for system improvements were not within vertical disciplines, but it was across disciplines. And so your comment about the Nobel Prize is spot on. And yes, there were big opportunities within our discipline for optimization. But when you look at an entire system, be it a workflow or a physical system, collaboration is the best. I will note that the winning team last year in Power the Community were not narrow discipline engineers working together. It was actually a bioengineering student and a computer science student, and their winning entry for the design in Zimbabwe kind of was more optimization across the horizontal than within a vertical. So that even kind of aligns with your observation on the Nobel Prize winners, is collaborating and finding opportunities across the disciplines. Everyone needs to bring their own knowledge to it, but by collaborating, that's where you get a supercharged result.
Thank you, Tom. Thanks. Any other? So just food for thought. Are you guys planning for any collaboration already? Do you have buddies already from different fields so that you can collaborate? I saw some chat comments in the chat also. We can read out that, and of course, I want to understand. You already have some buddies from different fields, as Don suggested, to work together. Okay, I think if there is no feedback on that, let's go to talk about the execution strategy. Okay, next slide, please. Thank you. So now let's say you are to plan this project. So of course, project planning is an entirely is a larger topic, but I want to give you a little bit of insight. Yes, ideas are great. We brought the team together. Now what? We need to have an execution strategy. We need to have a good plan, how we need to execute it for us to be successful, okay? So now let's say you were to plan the project, okay? This could be any project. The example I have, it's just one example. You can be creative and have your own project. How would you structure it? Here I'm giving you few simple steps to structure that, but it can be different depending on the project you select. Okay, I always encourage you to work on a prototype first, right? You have bigger ideas, start with a smaller prototype, test whether it works, understand all the quirks, how it behaves, do some validation in a prototype stage. It could be 4 weeks, right? Depending on the project you select. Build a basic AI sorting, in this case, shredding, solar powered setup, and so on. Once you finish a prototype, you go to a pilot stage, right? It's a little bit a larger one. Set up in a school community, right? Try to get into the real world, right? Set up in a school community center to collect data. And then you can do an impact analysis, right? How is the community receiving it? Well, we have a great idea. Now we have a nice piloting. In the piloting phase, you need to understand how the community is receiving it. You can collect feedback, and then you can do further iteration even in that phase to improve your product, right? You can do that. How you can do that impact analysis, measure waste diverted. What is the energy savings, right? All of these KPIs, when I say KPIs, this means key performance indicators. You can come up with a set of KPIs and measure all of this, right? And then this structure will help you to learn or turn your data into actionable plan. Okay. So I want to ask you something. So I'm sure as an engineering student, you might have done a lot of projects. What challenges you have faced in project planning? I think Don has a feedback. Don, you want to read it out?
Yeah, that was what I was typing was just a reply to I think it was
the previous one.
About Chris had some particular AI applications for electrical engineers, smart energy management, grid optimization, energy storage, and fault detection. But in this particular case, to your question here, your step-by-step implementation plan, it gets back to what we were kind of hinting at earlier about defining a minimum viable product or project and an hypothesis around it, and being able to test it in a very time-efficient fashion. So if something is going to take 6 months or a year to test, there's a way you can break it down and get some more focused tests that you could do faster on critical pieces. So deconstructing it and defining what the minimum viable product would be is probably the key to success in starting this project. A step-by-step implementation is getting it defined down narrow enough where you can actually do a very effective test in the short term. From my experience, there's other ways to do it, but that's a very powerful technique.
Yeah, I think there is one comment or a few comments in the chat. Judith or Nikhil, could you please read out?
Yeah, they're just commenting on the budget acquisition for hardware projects and proper mentor guidance. And then Shima Chris mentioned the scalabilities of how can these MVPs be expanded after initial success, challenges and solutions, potential roadblocks, and how AI can mitigate them. And then the community impact, how these solutions directly benefit local communities. So I think these may be questions.
Yeah, there's one comment that Raj has about budget acquisition for hardware and project proper mentor guidance. You always have to kind of sell the idea and get someone to fund it. That's a key one. The mentor guidance is one where I'm going to congratulate everyone who's on this phone call, because you're actually tapping into a worldwide network right now by calling in and starting to form your mentor network. So you got some people online right now with 10, 20, 40 years experience, me being the latter one. So just showing up is often a key to success. Most people, if you ask someone if they want to be your mentor, they'll hem and haw. But if you bring them like a little meaty problem and say, hey, I'm working on this problem, this is where I am, do you have any ideas? Most people are very willing to help in those type of things. So do seek out that guidance by bringing them your plan of what you're trying to work on. Don't be so bold to say, will you be my mentor? Say, hey, I just want to share what I'm working on. That kind of smooths things out, because most people feel underqualified to be a mentor. But if you ask them a pointed question about something they know, they're normally all in. So a little bit of a help and guidance there.
Thank you, Don. Thanks.
And maybe you can answer one of the questions, Jay, is how can these solutions directly benefit local communities?
Yeah. So the solution, how can the solution benefit local communities? Yes, definitely. That is a question. That's a great question. But when you think about a project as well, there is before you even put your hands on. That's why even Don was talking about the MVP, minimum viable product, and we talk about different phases of the project. This question can also be a part of your project itself, right? You can openly talk to the community. You can observe the community, right? What challenges the communities are facing. Is this a biggest challenge for the community? Is the community is in need of this? So maybe you may have to answer these questions at the outset before we start executing this project or even think conceptualizing project. Answering this question is so critical as a part of this project.
Okay, thanks, Jay. And maybe how can these MVPs be expanded after initial success?
Yeah, well, it's a challenge even for it's the biggest challenge, right? So definitely the one thing, of course, many brought the point of budget. Once you have an MVP, definitely scaling to the next level is one of the important element is budget, correct? So definitely you need to pitch this project, or you will need to project or show this project, gain visibility to this project in multiple platforms, similar to Energy Connect and other platforms. You can present this project, and there will be sponsors, and there will be community sponsors. There will be even government organizations who can help you fund this and scale it to the next level. But at the same time, when you have your MVP, when you are presenting your MVP, make sure you have enough details to explain them how you scale it as well. For example, in this case, okay, this MVP could process 50 kilograms of waste per day. But if we want to scale this to maybe 500 kilograms of waste per day, this is how this hardware system is going to change. These are the new things we need to buy. This is how the budget goes up. You need to have a plan, and also you need to understand the technical feasibility of things like that, correct? For example, when it becomes 500 kilograms, your AI sorting algorithm could be different, right? You may be receiving a different stream of waste. In that case, your algorithm has to be modified. So it doesn't have a single answers, but I can summarize this. Funding is important. You need to have a clear plan of how you are going to scale it. What does scaling means, right? Is it from 50 to 500? Is it from 50 to 1,000 kilogram, and so on? So as engineers, you need to think about like funding opportunities, and also the feasibility of it, and also the new challenge or the new scaling challenge you are going to face. You have to factor in all of those and bring up with a nice, crisp plan. I hope I gave a long answer. I hope that answered the question.
I think he did. Don mentioned something and he summarized it a little bit. And I think, Don, if you want to say that, I think that might be helpful just with the competition.
Yeah, Jay said just a little while ago that, observing your community, noticing their problems and pain points, and opportunity is the place to start. I don't know if he had a chance to read our details of the Power of the Community application, but I don't think it's an accident. That kind of wisdom of where to start a business or where to start a solution is always with observing the potential customers and their pain points is spot on, because our first deliverable in the Power of the Community competition is defining your community's aspiration with regard to energy affordability, sustainability, and reliability. Again, I'll go back to the winner last year for a community in Zimbabwe. They do have local power utilities that were available, but the power wasn't reliable. So the product and the community design that was defined in the winning solution was to supplement the utility with community and residential solar with battery backup. So that way the houses could have 24/7 internet access and 24/7 refrigeration, even if the grid was not delivering reliable. So they didn't try to solve all the problems of the community. They tried to solve the most pressing problem, and that's where they were advocating to invest the first dollars in those type of solutions. So spot on, Jay. I don't know if you read our competition portfolio, but I heartily agree with your observation. Observe the community.
I did not read it, to be honest. I will go back and read it. I think that also motivates me to learn more.
Yeah.
I think now the interaction is at a peak. I think Judith must be very busy
Yes, happily.
monitoring the chat.
Yeah, so
Okay.
we had Shima Chris mention something. He said since expertise lies in IoT and AI, we could explore solutions like AI-driven energy demand prediction to optimize distribution, IoT-enabled microgrids for rural areas, ensuring energy independence, and smart sensors for real-time fault detection in electrical networks. So I think, Jay, these ideas kind of fit perfectly with what you're talking about.
Yeah. Yes, Judith. I think now, I think we are in perfect agreement.
Yeah, great
Okay,
response, Shima Chris.
great. Okay, now let's talk about a little bit about optimized budget and prototype. I think the word budget came right. A budget is an important driver, correct? So here for this specific project, I have come up with a budget for a prototype. What would be a cost for a prototype, right? Here I have given some details, but it is don't take this as a very rigorous analysis. I just did a very preliminary analysis of what we can do, how we can do this in a prototype level. Okay, so I was thinking of a total budget of less than even $600 only. We need to have a power system. I just brought all the market price that based on current market price, but this may not be 100% accurate, just a caveat. Okay, but just to give you an idea of what components is required, and like of course the vendor price could vary differently. What do you need for a recycling mechanism, right? We need to have a repurposed shredder or blender, right? That could be a cheaper one. You need to have a 3D printed or metal plates, right? What do you do with the plastic waste you get, right? So then AI and computing, correct? You can minimize or cut down the cost a lot with this Raspberry Pi like hardwares. You can buy, those are pretty cheap, right? The Raspberry Pi. I'm sure many of you are using Raspberry Pi in some of the interesting projects that you are already working in school. You can have a micro SD card, power supply, optional. The Jetson Nano is an NVIDIA product. You can also use that, which is also not very expensive, and the price is coming down, right? Like I put $90, but you can also get it for $80 now. The price is coming down for those IoT sensors. There are different sensors. I'm not going to get in the detail of these sensors. These are like available in different markets at different prices. Of course, the software is now free, right? The TensorFlow Lite, you can use it, but again, there is so much advancement happened in the Python world or the AI world, and now you can use AI tools like ChatGPT to figure out how you train these models and so on. Okay, so this is just to give you an idea. We cannot ignore this, right? Of course, when we conceptualize a project, we cannot ignore budgeting. So I have added some insight to it, but definitely, as I mentioned to you, this is not the entire detail. Okay, just to give you some motivation and to give you an idea of a budget to develop a prototype.
Oh my God, this is such an awesome example. I mean, what you're saying here is that for very low capital, you can come up with an app or apply AI to these targeted MVPs.
Yes.
I mean, you're saying for less than $600, you can do an MVP.
Yep.
So for all you people tuning in, this is like $1 million idea that this type of insight can supercharge your career or even possibly be a nascent business. $600 is still $600, but if you have a winning idea, that might be kind of easy to raise either within a company or within your community. So I don't know if you saw it, Jay, but I had just typed, "Hey, my hypothesis with the recent announcement of DeepSeek just showing how little power, the reduction in power for AI, and that it could be put on local devices and not tied into the necessarily large surveillance system, that that you're going to see a lot more AI applied in an edge type computing environment. And I was an hypothesis, and now you're bringing the goods and saying, yeah, this is how to go do it. Is that correct?
Yes. To start, to begin with, right? Like we conceptualize it now. Why don't we experiment, like in a prototype level, buy these equipments, right? These are available in the market for these prices, correct? Now, of course, we are not the know-how, right? Everything, but we can put together something. There is so much information available from previous project. We experiment this in a school, lab scale or a small. Show it like this is an MVP. Now this is a capacity. Hey, this is how it does it, and these are all the challenges. Yes, we can do this.
Wow. Okay. Thanks. Well, I'm on board. I think you got it.
Yeah. Of course. Just to add some feedback about DeepSeek as well, right? Like the DeepSeek also, Don brought a good point, right? The important thing that if you read their white paper, right, the DeepSeek's white paper compared to OpenAI and other LLMs, the breakthrough they have done is instead of doing a brute force way of using the LLMs, right, they used it more algorithmically, correct? So, for example, whenever you query something in ChatGPT, the resource consumption is huge because it takes the information and the bigger model is running all the time in the background, correct? But the DeepSeek engineers, what they came up with is a simple idea. It's a distribution of resource, correct? They call something called the mixture of experts. So depending on the query, it's not really running the entire model in the background, and it is going to smaller LLM that is only required for that purpose. And so now the computational power is significantly reduced, right? So this is one idea in the white paper, but there are some other ideas they have shown you. But if you want to have like a discussion, if you are really want some discussion about this LLM as well, we can also have that discussion. These are somehow, sometimes why I'm saying this is budget is always a barrier, right? We do not have infinite resources. It is a challenge. But what can I do with this is how we need to think.
Yeah, I think I read where is trying to tap 50,000 experts, where DeepSeek only has 2,000 experts, and then they go get the one they need. So why pay for the computing power for 250,000 experts when in most cases you can get in the ballpark with a much smaller set? And then if you actually think about these edge computing things, is you don't even need to have 2,000 experts sitting there doing the computing. In most cases, if it's just a single application, you can get by with one or two, so you can really scale down the cost, and you don't need that overhead. I think it was a brilliant insight.
Okay, let's have I think the next slide is more of a closing remarks, right? So to wrap up here, what we learned today, correct? So AI can optimize recycling through automated sorting. Solar power can make systems sustainable and off-grid compatible. Engineering is a collaborative field, right? When multiple disciplines come together to solve the problem. Even with a limited budget, impactful solution can be designed with a smart plan. Okay. I hope this session has inspired you to think about how engineering skills can contribute to sustainability projects in the future. So basically, that is my closing remarks and takeaway. I hope you heard my closing remarks. So
Could you repeat your closing remarks, Jay? Sorry.
Yeah,
could you
please, can you? So okay, the first thing, what is that? AI can optimize. AI is a technology. It is not limited to any of the field. AI is spread everywhere. Everyone has to use AI now. AI can optimize recycling through automated sorting and efficiency tracking. Solar power can make the system sustainable, correct, off the grid. Engineering is a collaborative field. Okay, we need to recognize that, and we need to have multiple disciplines coming together to solve the problem. And of course, the important point that we discussed at the end is even with the limited budget, impactful solution can be designed with smart planning. Okay, and I hope this session has inspired you to think about your engineering skills and come up with a project that is needed for your community and execute it. Thank you so much for having me. And one request I have you have everyone for in this call is, so I think the online poll, I hope it went well, but if it not, the administrators will get back to you to answer those polls. We want to understand the insights. Yeah, understand more from you. We want to also understand what kind of project you are interested to learn more. That way we can make some of those subsequent sessions more effective as well. Please answer those polls. And of course, many of you use LinkedIn. This post is advertised in LinkedIn. Please like and share so that many people have an opportunity to see or get the value of this talk. And that's it. Thank you so much, Judith, Don, and I would appreciate you to take it from here and summarize.
Yeah, so thank you very much, Jay. You kind of threw out an example and thought model so that people can use it in a number of ways. A very narrow application is if they're thinking about their entry for the Power of the Community competition, that's one. But I think you went far beyond that. Some of the methods and opportunity you brought out would be very applicable if any of these students have intern jobs between their semesters. They can bring to their work, and especially in their career. I think particularly exciting, and I found it exciting, is that the example of how you can use, for under $600, you were saying that you could apply these advanced tools and sensors to projects and products that can improve operations. And you gave one example, but I would hypothesize in any operating business or factory that these opportunities probably exist in spades. And even for those that are not PhD type deep researchers in AI, I don't think that's where all the money is going to be made. I think a lot of money is going to be made in rolling out these applications to these existing processes and improving our base economy. So I think you just gave the listening audience some tools and thought models where they can supercharge their career and their economic opportunity. So thank you for that. That's my reaction. Anyone else? Judith, do you have any reaction?
Yeah, no, I thought this was really applicable and something that gives someone an idea, and then also how to execute that. So I think, Jay, thank you. We got some more insights into maybe how someone can complete the competition. And we got a lot of good feedback. I mean, we had a lot of comments and back and forth with students, so I really appreciate everyone on the call. And please feel free to reach out to Ian or myself, and we will get you in touch with Jay if you would like him as a mentor for your project, or you have further questions, or Dawn or I can answer them as well. So look forward to talking to everyone.
Yeah, we did have one feedback that we could make this more accessible to the worldwide audience if we had online translation. I don't know if there's any AI apps for real-time online translation. If anyone knows of any, we could run our own little MVP in that. And if they're not available, that may be a product opportunity for someone. That would really, I would think that would be widely usable. But I would think there's something out there. We just hadn't thought to do that in the past. So thank you, Malaz, for that suggestion, pointing out our opportunity there. I don't know what it would take for us to implement it, but we'll think about it. So Jey, thank you. Really, as you can tell, I really love your example about how people can do small MVPs for $600 or less. So that's great. And thanks all for tuning in. And we look forward to if you are competing, hopefully you are in Power the Community, your entries. And I hope you got some value out of this, that not only just for the narrow competition, but our general discussion about innovation and how to move practical projects forward by tapping mentors and defining minimum viable products. Hopefully that's something that you can use throughout your career. So thank you, Jey. Let's give him a round of applause.
Thank you so much.
Thank you, Judith, for arranging this. Thank you, students, for showing up, and thank you, Night Owl, for running the tech so everyone can get together in this virtual collaboration. So bye, all.